Okay, the following are properties. These are review properties from pre-algebra and algebra 1. Rules for exponents. We've talked about these already this year once. If I have two bases, such as x and x, they are the same base, but they have two separate exponents. X to the a, x to the b, what are you going to do with those two exponents? You're going to add them together. Why is that true? Because if I have x squared times x cubed, that means I have two x's over here and three x's over here. Give me a grand total of 5 x's. So if we add those two exponents together, it gives you x to the fifth. Over here, same exact concept. You'll have x to the fifth divided by x cubed. Well, I have 5 x's on top and 3 x's on the bottom. Give me a grand total left over to be what?
X squared.
X squared, which gives me 5 minus 2 to give me x. 5 minus 3. Gives you x squared. Do we understand that, yes or no? So when they're attached by multiplication, you add the exponents. When they're attached by division, you subtract the exponents. Now, when you have the same one base with two exponents, x squared raised to the third power, well, what that means is I'm actually writing down x squared how many times? 3 times. So how many total x's would I have there? I'd have 6 x's total. Well, how would I come up with that an easy way? 2 squared times 3 to give me x to the 6. Anything raised to 0 power is always and forever 1. Only the stuff that's raised to the power of 0. I could have a whole bunch of junk in parentheses. I could have the entire alphabet in parentheses raised to 0 power. That whole alphabet is 1. If I tag on an x squared at the very end, then it's 1x squared. I can't get rid of the x squared. I got to tack that on. Now, we've talked about properties 5 and 6 for a long time. If it's negative in the numerator, make it positive, it goes where? In the bottom. If it's negative in the bottom, make it positive, it goes to the top. xy raised to the a power, all you're going to do is tag on the missing exponents and distribute that in there to give you x to the a, y to the a. Over here, what? A little bit, kind of like you. Now, if I have x to the a, y to the b, and I am raising it to the power of c, you're simply going to multiply the exponents together again there. So, here we go. Now, you've done this already. Many of you are going to try to do this any way you want to do that you remember back in your Algebra 1 class. I don't care, that's fine, but if you jack it up, I'm going to say do it my way. Numbers with numbers, letters with letters. Numbers with letters, numbers, letters with letters.
Repeat that slowly.
Numbers with numbers, letters with letters.
What is it? What's next? Your last name with letters.
That would be fun. Now, do I have any exponents outside of the parentheses? No, I do not. So therefore, how are all of those things attached? By multiplication. So since they're all attached by multiplication, what can I do? I can simply rearrange them and put 3 times negative 7, x to the 4th times x cubed, and y to the 5th times y. That's totally legal. All I do is I rearrange them. It's like you're sorting out your piggy bank. You take out all the nickel, dimes, and quarters, and you put them in piles. Right? What's 3 times negative 7?
Negative 21.
How are the x's attached? So what do I do with the exponents? So that gives me x to the 7th. How are they attached here?
Multiplication.
This is going to be understood to be a 1 there. So what is 5 plus 1?
Y.
Y to the 6th. Done. Here we go. Next, what do I do?
You write down
I
the
know,
problem.
write down the problem.
You got to distribute the board.
Yeah.
If they're attached, if it's attached by the way, you would subtract.
You would subtract. Or you guys either add or subtract or anything. The biggest thing you want to do is get rid of any parentheses with an exponent on the outside. Do I have any of that going on there?
Yeah.
Oh, yeah.
I do. So we got to get rid of that parenthesis. So I'm going to put on there missing exponents on every single term up there. The 2 is missing an exponent, the x is missing an exponent, the denominator of the 3 is missing an exponent. Why did I put missing exponents on there? Because those are all different bases. Do we get that? So since they're all different bases, they all are required to get that exponent with its in parentheses. So negative 2 to the 1st, I'm going to simply multiply. So it's negative 2 to the 4th. Multiply here, x to the 4th. Multiply here, y to the 12th. Drop down the x squared.
2.
We're not there yet. Here, that becomes 3 cubed. X to the 12. Y to the 9. Now, why did I put parentheses around my numbers? Why don't I have parentheses around -2? Why don't I have parentheses around the 3? If you owe somebody $2 and you have $2, that's tremendously different, isn't it? There's a tremendous difference there. Which means you have to take into account that negative is part of that number. So what's a -2 times a -2?
4.
Times a -2
Positive.
is a -8. Times a -2?
Positive.
Positive what? 16. So this gives me a positive 16. Do you see that we had to take into account that negative? A negative times a negative times a negative times a negative is a positive. Do we all understand that? How many x's total do I have up there? Give me a grand total of 6y to the 12 all over. 3 times 3 is? Times 3 is? 27. X to the 12, y to the 9. Now, from here, you guys can do this problem 2 different ways. Okay? You guys can do the numbers with numbers, letters with letters thing, or you can simply use logic. If you're using logic, how many x's do I have up top?
6.
I have 6 of them up top, so that means how many do I have on the bottom?
6.
I have 12. Those 6 go away, and how many am I left with down here? 6. How many y's do I have up top? How many y's do I have on the bottom? So those all go away down there to leave me with y to the 3rd up top. Give me 16y cubed over 27x to the 6. That problem is done if you use logic to figure that out. Does that make sense? That's being logical there. Now, if I want to use the properties, I say to myself, well, how are the x's attached here? By division, right? So you're subtracting the exponents when they're attached by division. So 6 minus 12 and y to the 12 minus 9. So what is 6 minus 12? And what is 12 minus 9? Put that over 1. What stays and what goes? The x over 6 goes, and what I'm going to have here is 16y cubed over 27x to 6. Same exact problem done 2 different ways. It depends upon how your brain works. Now, here's what I'm going to tell you guys. If you're going to do it this way by adding or subtracting the exponents, it's a new word.
Operator error.
No, it's done for today.
Hey, don't say that.
I just did what you do.
The board is going to tell the Board of Education.
Okay, if you do this either way, what I want you to understand is get rid of your negative exponents last. I didn't touch my negative exponents before, did I? I added or subtracted first, and then I got rid of my negative exponents. Do we all understand that? Okay, what's going on with this a plus 3 raised to the negative 3? How has everything been attached so far? By multiplication. But what's going on now? They've been attached by multiplication and division. How are they attached now? They're attached by addition now, which means that's the head and the body. But guess what? The head and the body makes up an entire what?
Human.
Person, right? So this whole person is out to the negative 3 exponent. So my question to you is, does A, which is the head, and B, which is the body, do each of those get the negative 3?
Yes.
Or does the whole thing get the negative 3? Very different question.
A and B.
So my question is it going to be A to the negative 3 plus B to the negative 3, or is there going to be A plus B to the negative 3?
First one. A to negative 3 plus B.
Did you ever walk around with your head unattached to your body?
No.
No. Which means this is wrong. Which means you're simply going to put this over 1 and eliminate the negative exponent. So how do I eliminate the negative exponent? 1 over A plus B cubed. Done.
That's it.
Yep. Why is that it? Because they're attached by what? addition. Okay, what do I do with this one? How are those two bases attached? So what do I do with the exponents? So 2 to the 9 plus -6 gives me 2 to the 3rd. And what is 2 times 2 times 2?
8.
Number 5. What do I do here? How are they attached? Bases. Attached by division. What operation are you doing to your exponents? You're subtracting. So I have 5 to 6 minus 8 to give me 5 to the -2. Do we like negative exponents? So what do you do? Put it over 1, and that becomes 1 over 5 squared to give me 1 over 25. Now, if we had these logic skills at the get-go and said, hey, there's 6 up here, so that's gone, and that makes this 5 squared to give you 1 over 25. Could have, right? Could have. All good back there? Not gonna lie, that was really gross. Hey, how many bases do I have there?
Oh, 2.
Abby really is uncertain, but she's right. There are 2 there. Why are there 2 there? Because 2 is a very different number than 3. So that's 2 to the first, 3 to the first. Do we understand that? Now what do? Distribute that negative to both of those. That's going to give me 2 to the -4 over 3 to the -4. Do we like negative exponents? So what goes where? 3 goes to top, 2 goes to the bottom. Now, we normally do addition or multiplication better in pairs. What's 3 times 3?
3 times 3.
9. What's 3 times 3? So now what's 9 times 9?
81.
Do we understand that there's 3 4s there? 2 times 2. 2 times 2. 4 times 4. 16. Done.
I don't get is, but why do you have to give the 2 and the 3 exponents?
Because there are 2 different bases.
What if those 3 over 3?
Well, what is 3 divided by 3?
1. So you distribute the 4 to 1.
Anything raised to 0 power?
1.
1. Well, how about this one?
1.
What's the answer here?
X squared times 1.
This turns out to be a 1. This turns out to be a 1. Which one am I left with then?
That's a C.
Yep. That's fast.
So the answer is X squared by 2.
Yeah. Tonight's homework is that. Write it down. How many people brought your books?
Take 2 to 18 off.
I was bringing mine.
Thank you.
I was bringing mine.
Bad. Bad, bad, bad children.
Well, you didn't start having us do stuff out of the book, so.
I think I'm going to do it every day now.
Jen,